Hello, friend. In the market for some hunting supplies? What are you hunting? Never mind. I don't want to know. So we've been playing Skyrim. It's totally in my brain. I can't stop but hear the music in the background. Yeah, it's kind of a thing. Oh, there's a game called Small Towers. Where is it? Where are you? Small Towers, where'd you go? Small Towers! There you are. Okay. There's a game down below called Small Towers because this cartoon ape enjoys making games as well as playing games. You know? It's true. So the bots will demonstrate this game, and that is fun. If you say like, oh, so I use small help? No, the answer is no. There is a way to queue up and be a part of the game. Once you're in game, then you can use small help. And this game is here for you. So if you're like, I'm just going to ignore what's going on screen and learn this game and use small help and make this big cheat sheet appear in the middle of the screen, you know what? I don't mind. I'd rather people learn the game, and there's a small learning curve. It's not much, but you recruit troops and then you attack, retreat, or hold. You can build, cast spells, upgrade, blah, blah, blah. Okay. We are continuing Design Workshop, and I say that's a significant thing because in Design Chat we talked about this. We didn't have to. We kind of stopped at a great place. It was Design Chat and Design Workshop 20. 20 is a nice round number, and yeah, but as we talked about in Design Chat, there is some sense in continuing. So in Design Chat, we talked about it and we said, yeah, okay. Because we made core gameplay. This game actually runs, and yeah. And then we said, there is more to do. And the reality is, because it's the design process, and the design process can be, you can come back to the design process and get through any problems. That's a good thing. It's also the case that it could be a never-ending process. So stopping somewhere, especially after the milestone where we got the core gameplay, modest player control, a win and lose state, the player agrees to the rules, and we're even replayable, well, that seemed like a logical place to stop. As we talked about in Design Chat, all right, we'll continue, because at least we can demonstrate that this same process can help solve any problem. At least we can apply these same processes to level design. I mean, and that's what's left. We make levels. That's what it's going to be. How many levels? I don't know. Is there a boss battle? Is there a narrative? Is there puzzles? Who knows? But the point is, and in fact that's part of the process that we can go through, is finding our way to a good design of levels, right? A good progression of levels, because we have the start, but then nothing, right? We literally say, just go to the wind square, that's level 1. Level 2, let's put a wall there, and so on. Design Chat said, okay. Design Chat even said, well, then let's use walls in this way, and we'll follow a pattern to introduce new things. This new thing is simply a wall, and we'll use a series of walls together. And Design Chat even went into the game engine to put in a wall. Go Design Chat. Yay. Said a Design Workshop, we're going to talk about this, because there's some problems. Let's go look at the problems and come right back. Yeah. First of all, let's just celebrate again. This is our game. Wow, cool. And indeed, it is pretty and fun. Here's our little dude. This is you. Use WASD to move. WASD. And go here to begin. Oh, okay. I can move her anywhere? Oh, cool. Okay, cool. And I go here to begin. Okay, there we go. All right. Level 1. Ready, set, go. Is it a race? What's going on? Oh, it's shrinking. Oh, I better get there quick. There we go. Level 2. Now, Design Chat has already put in a wall. Right? So this is level 2. This actually is like level 2. And I can't get through. Okay. And it comes back here. Now, Design Chat did add level 2. Go. Design Chat. But in the process, Design Chat found a problem. Level 2 works fine. It really does. Oh, by the way, we can talk about cheat codes and why they were developed so you could go immediately to level 2. I mean, we can do that in the engine because we're here in the engine. I could just say level 2 and start here. But cheat codes were developed to help the testing process and find the issues quickly. I don't have to go and play the game all the way to the boss to test the boss level. Right? You just cheat and get there. Right? This works fine. This does what a wall does, right? Wall. We found a color to it. We put a thing. There's even a prefab for it because Design Chat did all that work. Here's a wall piece. Boom. Excellent. How did we make it? Well, we were remembering the process. I'll get rid of my avatar for now. Oops. We were remembering the process where we played with how to detect the player is in the win square. And we played with, triggers and things where this square used to have a collider on it set to is trigger. Here's another similar thing. That's a quad with a renderer just like the win square, but it has an extra piece, the collider. And we were playing with is trigger for a while, but when we weren't playing with that, this was solid. And we said, oh, that's great. We should use this as a wall. Hence the whole progress toward maybe using walls in our game, right? Well, this works great. What's the problem? Let's just go, right? Well, Design Chat went further. Good job, Design Chat, because testing the walls for what we wanted to do was the thing. That was a good thing to do. Good job, Design Chat. They said, we said, we were Design Chat, but I'm just saying they, just to separate it. In Design Workshop, we make things. In Design Chat, we talk about the best practices of design. And so here's, best practices in terms of sketching it out here first, because this was fast, and realizing, well, that would probably be too much. Let's go for something a little simpler for level 3. That was quick. We didn't have to build it to find that out. We just sketched it. It was great. That's a best practice. Well, here's another one. We got walls that come together like a little passageway and things. We want to do something like this where the passages all come together. Well, we're going to have to zoom the camera out probably, but also there's going to be a passageway. There's going to be a, sets of walls together where the passage in between is big enough for our character, and that's how we can make the maze. It's as much about the passage, the pathway in between. In fact, finding the path is the new skill the player has to learn. But in making it, we actually need to make sure that we can get in between the walls. And, oh, by the way, we also discovered the idea that the player could just go off screen and go forever because there's nothing holding them in the screen, and we probably should put walls on the sides. So, not wall, because wall worked great. We just saw it. But walls. Design Chat went through the process of continuing to test this because we know we want multiple walls. So, yes, let's go in and just test walls. Good job, Design Chat. So today in Design Workshop, we're going to see the problem. Let's go to the problem. This was the wall prototype scene that they made. Boop. So, good job, Design Chat. Now, let's time for Design Workshop to crack our knuckles and look at the problem. We put walls, in fact, here's the wall piece prototype, or the prefab, meaning we now have a folder for environment, and we put, we made a wall piece, but then we threw it in here to make a prefab of it, right? This is, just a copy of a prefab. There's another one, right? And it's good, excuse me, let me just delete that. It's good to have this because if we make a change to this, like the color of it or anything, all of them will have that change. We put two together under a third empty game object and called it a hall piece because we were concerned about, what is the right thickness of walls? How are we going to put the walls in place, like on the grid, where I'm holding down control right now to make sure it's snapping to the grid? This was, good job, right? And we did it so that we could actually test this. What's the right thickness? Well, Visually Design Chat said, well, let's compare it to the thickness of the lines of the character and say, it needs to be at least this thick to look like a solid piece, just to look like it, right? And by the way, let's test the actual working of the walls. Now, the walls don't need to do anything, right? Well, check it out. Level 1, ready, set, well, we don't need to say level 1, ready, set, go. This is a testing scene. But check it out. I can sort of run into the wall, and then I can run into the wall, and I can run into both. Whoop, wait, what? What's going on? What's going on? It's too hard to see what's going on. Let's fix our test scene, first of all. I mean, they did a nice job, but we need to fix this. Our wall prototype scene doesn't care about the wind square, actually. Let's just turn it off. Don't have to delete it. We can just turn it off, and it won't do anything. That's good. Let's just save this again. So now this wall prototype scene is only looking at two things, the player and walls. The rest, I don't care. This text display will be ignored. Great. Done. Let's look at this again. Oh, good. There's nothing to say ready, set, go. There's nothing to hold the player. If you recall, the game manager's the thing that freezes the player. So everything's like just good. I can just test. Good. So again, wall. Wall works great. This is great. Now, walls. Well, we learned that we need this much room at least, right, to get in there. There we go. In fact, what I'm doing is sort of gliding along this edge of the wall and then slipping in. And so I'm in between these two, and you notice it's kind of jittering. It's like it's trying to go in and it's being pushed back out. Well, this is physics. Oh my goodness. Did you see that? I just went through the wall. I can cheat my way through the wall. Well, that would be a problem, isn't it? I wonder how that happened. But you can see the jittering, right? Well, maybe that's a key to how that happened. I just went through the wall. Did you see that? Can I do it again? I'm gonna try. I'm trying. And so it's jittering back and forth because, yeah, the character is solid. It's got an extra physics component on it called rigid body because it's just one little square, an invisible square with our character's face on it. And then we have our script on it. Our move character script is trying to move in a particular direction. It's literally teleporting every single frame. Our move script is made to move our character around because frame by frame we say move just a little bit over and just a little bit over, and it's a tiny amount because the frames are going by really fast. And so what we're seeing when we jitter, we're seeing a frame where it is actually inside the wall. And then the next frame, the collision of the wall and the interaction with our character and the rigid body pushes it right back out. So it's in, then it's out. And that little jitter is slight movements in and out of this wall. In other words, we are actually already breaking the wall's integrity by jittering like this. But get this, if I force one wall to push me into another, I'm being pushed back with this one. What if I try to go to the to the left now. Yeah, one wall can push and cheat me through another wall. So we saw this in design chat and said, oh, okay, we're out. There's a problem. And it looks like a technical problem. Let's leave it for design workshop. Okay, so like I said, we're going to crack our knuckles and solve this problem. But this is a problem. We want walls, not just wall. Wall is fine, except for that one part where we cheated through the wall. Maybe we can solve both of this. Maybe it's the same problem. That would be great. But testing showed us the problem. Good. That's a good thing, because now we know to focus on it. Man, it's a good thing Design Chat tested. It's a good thing we are testing, and it's a good thing we're seeing the problem. This is a bug? Yay! I'm not joking. That's a really good thing. We found a bug? Oh, good. Because imagine we give it to the player, and the player's like, whoa, what? We would be sad that we didn't fix that bug. So it's a good thing we found the bug now, because we can fix it. You see? It's gold. It's good. We found a bug. Yay. So I can go straight down. So I'm between these walls, and we thought this was a good spacing. It's at least just wide enough to go through. But I actually think I need to cheat that same way to get inside, because this is exactly 1 unit across. It's exactly the width of the character. It's physics from both walls actually pushing him exactly in place in the middle to be able to go up and down easily. In other words, we've got one problem. The problem is related to the jitter. The problem is related to even being able to get in here. The problem is related to the walls allowing you to cheat through other walls. And I think we can also say it is related to how our character moves. If you recall, we have a script doing animation, and we have a script doing movement. To make our character move smooth, we iterated on this one move script, and it does look smooth. But now we're trying this, and first of all, the jitter does not look smooth, but also problem. I mean, this problem is actually bigger than anything that we have so far. And we can translate it to just our design process and say, this is now a need. The player has a need to not cheat. That sounds counterintuitive, but it's true. The player wants the game rules to have integrity. The player needs the game rules to be consistent. And this is consistent until now. Now it's not consistent. Right? This cheating is like not consistent. And the player actually wants us to fix this. Facts? Cool? True? Yes? We're in agreement? Then let's fix this. Yes, I think we need to look at the player's movement script. This is the one script we use to move the player, and the animation is completely separate. Oh, thank goodness, we only need to go to one spot. And, oh, thank goodness, we don't need to mess with anything else. The animation is looking great. Let's keep it that way, right? The movement is looking great, but there's something wrong with it. And I think the first thing is this jitter, but then this is a big problem too. How do we allow this normal collision stuff that's going on with physics on the character to do what it does at the same time our cool movement that looked like this just working, right? And is there a way to also just deal with this jitter? Like this jitter alone might be something we need to look at. Again, every frame I'm basically teleporting. Boop, 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 boop. I'm exaggerating here, and the animation is helping me exaggerate it. But the point is, I'm not smoothly going in between this position and that position in between the frames. It's frame by frame, teleport to a brand new position somewhere else. And that's the only reason why we would be inside this collision, because otherwise the collision would say, no, you may not pass. None shall pass. Right? Well, right now we can say, oh yeah, watch me, I can pass. So let's fix it. What we're talking about is character is a square. Remember that this is the character. Like, boop, 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 boop. They are a square. Now they're an invisible square, and then we put a character's face on it, right? So this cute character is not actually colliding with anything. It's just drawings on top of an invisible square. This is what's solid. And this has a center that we teleport a little bit, a little bit, a little bit, and that's how it moves. This wall piece is also solid. It does not move, thank goodness. But, I mean, I guess once we figure this out, it'll be fine to get this to move. But the point is, this is also solid. And this is what is happening. What I just said was, one frame, the character's right here, with its center right here, and then it teleports here, which means it's inside the wall. And the wall says, nope. And the very next frame, it pushes it back out. That's the jitter we're getting. This is also, I believe, why if there's two walls here, and the character's right here, it could be trying to move in this direction, and this wall says no, and pushes them this way, but they're still down. And so, guess what? They've just gone through the outer edge of the wall, and they're free to move. That's what's going on. Physics works like more calculations than the number of frames. It's trying to be accurate. But what it is trying to do is detect this edge and that edge. In fact, it's not unlike what we did with the win square and our buttons. We said, can we detect that the player's all the way inside? And, you know, here's the center of the character, here's the center of the win square, here's the edge of the win square, top and right. Here's the edges of the character, and we did a little math to make sure it was inside. Not really math. We just did 4 different checks for the 4 different sides and said, yep, it's inside. This is not much different. Physics does the same thing. Instead of looking at, are we all the way inside, physics says, you know, are you at all inside? But doing the same calculations, you know. Well, could we do it the same way? Could we make our own collision detection? Actually, yes. But, I mean, we kind of did that trick like twice like already. We can move on to a different trick. And also, we can graduate to working with physics. That's okay. I mean, this already comes for free, and it's kind of nice that, like, one wall works. That's good. Can't we just get more walls? This problem, where one wall pushes us into another one, is really highlighting a deficiency where we teleport the player one little bit, because physics isn't expecting us to do that. Well, long story short, we have an opportunity right here where we say, I want to teleport one tiny move. We have an opportunity to say, wait a minute, are we in any other wall? And we can say any wall. We can ask, is this inside any other collision? Remember, the player is solid. That's how this works. But we're going to ask, is there any other solid thing that we are going to overlap with or touch if we move this one tiny little bit, because the player wants to move in this direction and we're going to check that. If so, let's ignore that move. Like, let's say the player's actually wanting to move down and to the right, and we check this right direction, and that hits something, but the down does not. Well, sure, then we'll just ignore the right and let him just move down. This would, I guess, let the player slide down a wall. Like, if I'm going in this direction, and I'm right here, then I would be prevented from going to the right. Right? we can ask, is this going to be colliding with something? And if the answer is yes, then ignore that one. And if you recall, our movement script evolved from going from 4 directions, because that's what we thought we needed in the beginning, to saying, oh, wait a minute, sometimes we want smooth movement, and that turns out to be going up plus going to the left because they are pressing both W and A. That means we want to add this up vector and this right vector together. And we get this diagonal. So now we can do diagonals, and it's very smooth and cool. Well, if I'm going down and to the right, same thing. This is 2 different vectors being added together. What we're saying is just ignore one of them if that one vector is going to get us in a wall. If we ignore that one but keep the other one, guess what? We're going down, and we're sliding down the wall. I'm moving this way. I'm against a wall. I'm now sliding down the wall. What I'm suggesting is we already have this movement script that does this cool thing where it treats each of these 4 moves as a separate vector we might add to the resulting direction. This up plus this left equals this diagonal up left. And we already do that. Yay. Let's take that. Let's take that win. If the solid of the wall can be detected, if we can ask the question, here's a solid wall, now let's test a square the size of the character at this location. And if that test comes back that we hit something, anything, then we can ignore one of these 4 directions that the player is trying to do. We can keep any direction that is free and not touching anything. And so the resulting vector move can change from what the player thought they were trying to do to what we can actually allow them to do. In this case, excuse me, I'm struggling with the tablet. In this case, you can only go straight down because to the right there is a wall. In other words, we're asking 4 questions again. Excuse me, I'm very sorry. I need coffee. And in a jungle, coffee is life. It's true. See? Stream Elements agrees with me. So, what are we talking about? Design Chat found a problem. Design Workshop's going to solve the problem. The problem Design Chat found is in the pursuit of getting towards our next design work. Looking ahead and testing, they found the problem being 2 walls interacting with each other based on how we move. Design Workshop says, hold my coffee, and we're going to fix this. We know what we already have. We know what we can do with that. Let's see if we can implement it. We already have movement. The movement looks smooth, and the movement divides the 4 directions into separate questions. Is the player pressing W key, A key, things like that? And if so, add a vector to the resulting vector that we will move, frame by frame, tiny little moves, and teleport the player there. It looks smooth, let's keep that. Problem now is, this cheating the player can do is a result of that teleporting. So it's now just a new rule, a game mechanic, a game rule, in addition to the system of movement that we already have, if result position of a move vector. Now, we'll have to define what that is, but basically it is the up, down, left, or right. Because each of those is 4 different move vectors that we check if the result of a move vector position, right, this dotted square, oh my goodness, I need more coffee. It's the talking, and in the morning, that's what's up. If the result position of a move vector collides with anything, then ignore, and I suppose we could change this to be a positive, but right now I'll say ignore the move. Right? If I want to go to the right, but the result of that move vector puts us in a position to collide with anything, then ignore moving to the right. Otherwise, keep all the other vectors that you can move, and we're in business. This is one mechanic that we need to add. But it's asking a question we've never done before. It has to do with physics, and we need to ask, if I project a imaginary box, the size of our character, but just one little position over, wherever it is, doesn't matter. Can we just throw down a box somewhere and detect collisions? I mean, for one thing, we're going to need to recognize that if we are just checking one little square over, we're likely to be checking in a space where the character themselves is one of the collisions. That's true, actually. Yeah, the character is solid. And if we say, hey, let's throw down this imaginary square, is anything solid? It's going to say, yeah, you. The character is solid. But we can ask the question, is there more than anything else? Okay, anything else, I guess, is just in addition to that rule. So if the resulting position of a move vector, this tiny little move here, if that result position collides with anything else, like a wall, then prevent that move. Now, I'm saying this will prevent the jitter. I think that's true. I'm saying it will also prevent this cheating from happening. Well, let's test that theory. Let's find out. Again, thank goodness we have a test scene we can play with that is just easy to test. This cheating is the problem. Let's look at what specifically in our move script, because our move script is the only thing moving this character, thank goodness. We can just look in one place. Let's go look at our move script at how that cheating happens. Right? How can I get inside this wall? If it's solid, how can I get inside it? By simply going up and to the right. Like, check it out. Right? It's either going to put me through one wall or the other. It's actually kind of random which one it decides it's going to do, but it has to do with just where I happen to be. I'm going up, going to the right, up and to the right. Cheat. Right? So it's very consistent. Let's look at the script and see what we can see in terms of how it is doing that problem. That's going to be our key to figuring out how to solve it. We do have a plan. We want to try and get our character to check the resulting position first before committing to moving in that position. Because if we collide with something, we're going to say, no, don't do that. So I double-clicked on the script, and here we are. Let's look at this, because it's been a little while since we looked at this script. This was a while ago, right? We result in a move direction, and then we use that direction. We use it with time, and we say, here's a speed we can use with time, and we reposition the character, teleport them in this direction, by this amount based on time as well as a distance, yeah? We don't do anything in start. Looks like we do stuff in update. Is there anything else? Nope, that's it. Well, all right then. This will be easy. What do we do? Well, we only do something in update, so let's just focus on that. If no key don't move, okay. Good thing we put these comments, right? Move direction is vector 30, which is a shortcut for, shorthand for 0, 0, 0. So moving nowhere, okay? We set that, reset it every single frame, okay? Next. If the W key is pressed, move up. Now this is where we separately check each direction, right? And if, yeah, you're pressing W, right? Then we move up. Now this is the change we did. We actually just added one little plus sign, but it is, instead of making their move direction equal up, we said, let's add this vector. So it was 0, now it's got this up, which is 0, 1, 0. Okay, and we are adding these, so it's kind of accumulating any change we make. If we also move to the left, for example, we have a -1, 1, 0. If we added left and up together, that's what we would get. Because we're adding these vectors. That's what this says. That's how we got the smooth movement. We just made the little change of adding the vector as opposed to assigning them like this. We said, no, let's add them together. And we go through each of the forward things to add up whatever is being pressed. And then the result direction, move direction, is now applied to move speed, that is a distance, but then times time. And if you recall, this is the very accurate measure of time since the last frame, which is exactly what we need on update, called every frame, in order to change the position based on the direction, the speed, and that time. Reposition, in other words, teleport. Where this player is, add some vector direction multiplied times that distance. Yeah, that's how we're teleporting every frame. And this is the problem. Well, technically, it looks great. Right? It looks great, and technically this is the problem, but it looks great. So, conflict, right? What do we do? Well, I propose that we have an opportunity right here to ignore this direction entirely. If only we can check, hey, is there a wall if we go up from here? I don't really care about anything else. If we're going right or left, I don't care, but up. Is there a collision if we're going up? Because if so, don't go up. In fact, let's turn it around to the positive right now. Let's say if there is no other collision besides ourselves, I guess, if we test that square, if we can test a square and see if anything's colliding, and it's really just us in that one little direction up, actually, we probably need to check not just the direction, but this multiplier as well, right? We need to check that. Right, because it's not just the direction, but it's an amount based on how fast the character is going, how much time has passed. This is part of the equation. We need to say, we're going to move in that direction a tiny little bit. This is the tiny little bit part. And therefore, we can say that tiny little move, does that result in a collision? We need to do this. If no collision, let's just make it plain. If not touching anything else when up a little bit, I'm speaking plainly, but you kind of get this little bit actually translates to this amount. And the up is literally this instead of the resulting move direction. So it's actually up times that amount. Okay, I'll write that. Vector 3 up times move speed, yeah. It's move speed times the thing down there says time dot delta time. Okay. That. This amount is direction times the distance. That is distance times time is speed. We call it speed, but that's what that is. So if we're not touching, then move up. Otherwise, we should ignore this and just not add this vector. It's almost like we want to say if we're, pressing W and all of this, but we could just put that if statement in here. That's totally fine. In fact, this does look like a lot to calculate in one line. Let's not do it in one line. Can we move all this to a function? I ask, leading the discussion to add a new function. Because this is a function, and it's called by Unity, but we've made our own function before, I promise. Let's see, animate character. We made a function here. Yeah. This other script, we made a function that another script could call. We made a function down here we're no longer using. We should probably clean that up. But let's make another function. Let's make a function so we can move all this in there and then just ask the question, hey, are we touching anything? In fact, yeah, let's just do that. Hey, if touching anything, or let's say, let's make it a positive. Just the name of this function should be a positive thing. If touching anything as a name of a function You'll have to excuse me. I get excited and I don't want to stop, and my throat just seizes up and I have to stop and sip coffee. So that's why I'm pausing. Pardon me. Okay. The name of a function, that's what I'm playing with. And I'm stopping and thinking about the name to make it readable and all that stuff. I'm just worried about what do I name this function, that's all. But I want to say this is a function that's going to return true or false so that it fits well inside this condition. If the condition is true, then do that as the rule format, and that's exactly what we're typing in here. If. Now I could say not touching anything is the name of the function, but I'm concerned that the name should be a positive, and we can ask if it is not. And then the name of the function be touching anything. So I'm going to try that, touching anything. Now, this sounds trivial, but believe me, nerds and programmers care about this stuff. Yeah, we'll get there. This says touching anything, and I'm going to say this is going to be a function we will make, and it will return true or false. In other words, right here, when it says if, it will actually call the function and return a value. So that touching anything will be replaced by true or false. So I can ask the question, if this is false, okay? And that's the same as saying if not touching anything, okay? I'm just grammatically worrying about the name of this function name, that's all. But if that condition is true, where touching anything is false, it has been cold in the jungle as well, and I'm fighting to not be under the weather, so pardon me. I hate to be in the middle of a sentence and have to stop. Let me please redo this. The rule is, if not touching anything else, then then add the vector, okay? That's the rule we're trying to get to. And I'm saying, let's name this function we're about to make touching anything, and we'll ask if it equals false, because I'll have this return true or false. And then this will work. And yeah, we could put some curly brackets. I think that's fine. It's only necessary, it is not necessary because I'm just doing one line after it, but it is consistent and I will do that, okay? Well, now we got to make this function. I don't know what is in this at all, but we're just hoping we can actually do this. Okay? Let's make a function called touching anything. In fact, I'll just copy that. Let's go down here and make some space for it inside the last curly brackets, because that's the scope of the entire script or the class. But now inside here I can say there is a function called touching anything, and it's actually going to have a word in front of it. Sometimes we say void. That's just a placeholder word. Void means nothing. But we need some word here in order for this to work. I'm trying to describe this in logical terms. This would work. I need to put some word in here, and void is just a placeholder so that this can work. This is fine. But it doesn't actually return true or false yet. That's exactly what this is a placeholder for. It's a placeholder for the return value. It's a variable type we need to put here to say this function will return a value of this type. Right now void means nothing, so it doesn't return anything. But if I say bool, like a Boolean variable, this script is now going to return a value of that type, either true or false. It means I need to actually return something like that in order for this to work like that. But it does. Now this will always return false because I just typed it in, hardcore typed it in. That's not appropriate. But I can make a local variable here. I'll just call it the return value that is a Boolean. And by default it should be false, I suppose. But in the end, at the very end of this function, we need to actually return. We've used the keyword return before to just get out of a function. That's true. We've done that. But because this function needs to return a value, this keyword now has to be followed by some value of that type, either true or false, or in this case, I can just do my variable. And now this works. This pattern I do all the time where I set up a local variable to play with and plan to return the value in that variable at the end. What I've done is made a new function, and I just called it something that is related to the process it's going to do. I'm going to check here if we're touching anything. And I think what I'm missing is, based on this vector up, I want to reuse this function. This is not quite done yet because I'm ignoring the vector up. This is actually going to be the same. We do this the same all the time. It's really just this vector that changes. So I probably need something like this. I'm playing with it and saying I'm probably going to need to give this function which direction we're testing. Right? If we're touching anything in a direction, and I need to give it the direction. I think that's what needs to happen, which means that a vector3 variable needs to be part of the input for this function. So we talked about the output, it's a Boolean. Are we touching anything, yes or no? But the input could be here, and I'm going to say vector3 is our input. In fact, it's a direction, yeah. This is the name of the variable that is going to be used here. I can now use this. Right? But it must be there must be some vector3 value in the input whenever I call this function. So if I didn't have that, it says, you can't call that. The red squiggly says, you need to give me a vector3. And in fact, it even tells me the name of the variable I just wrote down. Dir for direction. Cool. So I expect, if we actually do this function, I expect to be able to say, are we touching anything in that direction? And if that is false, then we can add this vector. And I expect to be able to do that for all of them. I expect to be able to do this for all of them. Except I'm going to change with the vector direction. So this, but not up, right? We're going to go down. Or if you press S, we're checking to see if you have any problem going down. Are we touching anything? Right? And if the answer is no, that's what touching anything equals false means. We aren't touching anything else. Yeah. Cool. Let's continue that pattern. Oops. I feel fine when I start the stream, meaning I'm ready to go. And then I start talking and my throat seizes up. And I would like to, hydrate often and all the things that streamers do. But my hands are busy. I'm typing. I'm moving my mouse. I'm doing things. Yeah. Streamer problems, right? That's a me problem. It's not a you problem. Okay, so this pattern, I'm just being very careful as I paste code, being very careful to review what I just pasted to find the thing that's different. In this case, this. And then I'll review. We're not touching anything up, then move up. Not touching anything down, then move down. We're not touching anything left, then move left. Now this just reads like English, right? This is easy, right? Well, we'll do the work in a second. If we're not touching anything right, then we'll move right. Yeah, that looks good. So now it's time for us to figure out how we do this, right? Because we can ask the question in a particular direction. We can use this. Sure. Let's actually do that. This amount, I think it's a float because it's a float. Yeah, both of these are floats. So if I say I want to make a new float value that is, I don't know, distance, yeah, where move speed is a float and delta time is a float, and so you multiply this together, it equals the distance we will try to move, yeah? Cool. And that's true because that mirrors what we want to do here at the end. In the end, there will be a move direction that has been added appropriately because we did this check and we're safe to do this now. This is the same. It's going to look great as long as we can detect if we're touching anything. Yeah? All right, let's do it. Let's do it. I mean, first of all, this is always false, so we should be able to test this. Can we still move? I mean, I don't see any reason why not, but, it's always good to test. We're moving around. Okay, we're fine. And we're still cheating, so this doesn't work yet. Well, the difference we're going to do now is say, no, you cannot move. Because there is actually something in that little tiny space next to you, and it's solid. So no, little guy, you cannot. That's what we're going to say. How do we say it? Well, there is some beauty, and let's just stop for a second. There is some beauty to say we just put it in a name and put all that code somewhere else, and frankly made this look like English. If not touching anything going up, then go up. Right? It reads almost like the rule. Right? And that's by design. That's That is according to our best practices, right? That's why we have the format of the rules. So you can just do this easier, yeah? Okay. Now, how do we check? Now, this is the thing. Check to see if a box at a particular position, I'm going to rethink this, collides with anything else. Anything other than us, right? Because we have collision on us. I say us, meaning the character, right? This move character script is on the character. Yeah? This character has a collider component, meaning it is solid. I have a strong feeling we're going to say, yeah, is there anything solid here? And somebody's going to say, yep, you. I have a strong feeling of that because, we're not looking at the animate character script. This is a collider, and this is solid, and that will be true. So we're messing with this script now to just say, all that cool movement you do, just do a check to see if there's anything else solid. Like this is solid. Sorry. Get the avatar out of the way. Like this is solid, yeah. But let's see if this is there or this is there. Like go check in that spot. But we're going to have to ignore when it's us that it detects. Because it will always detect us. If we're only moving a tiny little bit, yeah, we're always going to be in the way. So we kind of need to ignore ourselves. All right? It's sort of zen, actually, now that I say it out loud. So here we go. Let's do it this way. Check to see if a box at a particular position collides with anything other than us. That's actually quite a bit of stuff. So we're going to be asking about all the collisions, I guess, because we're going to expect we are always in the way. Yeah. If it's this tiny little distance. Oh, by the way, the reason why delta time works great is because we're only calling this function inside update. Here's update, and we call this function here. We don't call it anywhere else. So this delta time value is still there, but it's relevant each frame, so that's why this works well. We could just as easily feed in that value, and that'd be fine, but this is okay. All right, I digress. Let's check to see if a box at a particular position collides. This is physics. Thankfully, this is super common, and thankfully there is a physics class. It's physics that helps us detect collision at all. That's what the rigid body thingy is. But let's just look at physics for a second. Physics, there we go. The class called physics. The global physics properties and helper method. I like helpers. Let's helpers. So I'm going to hit a dot to see what's inside this class dot. And dot shows me there is a lot of stuff. Box cast. Oh, wow. Box cast. That's nice. This actually says use a box and then project that box in a straight line forever and see if it comes back with anything. That's cool. There's something called raycast as well. There's capsule cast. Yeah, totally. Bro, check box. Check whether the given box overlaps with another colliders or not. Bro! No way. Okay, I could have... Okay. You may not get this lucky. Okay? We just happen to poke around in Visual Studio and ask what is here, and it just so happens check box is right up at the top of the list in alphabetical order. But if you're not that wildly lucky, you might also just Google basically all of these words that we wrote down here, and you'd probably get exactly the same thing. No joke, actually. Check box. Literally, it gives us a true or false. But wait, here's the problem. Checks whether a given box overlaps with other colliders or not. We are certain we're going to overlap with ourselves. So that actually guarantees it will always be true if we only check right next to ourselves. Yeah, let's keep looking. Darn it. That would have been great. That's okay. There's always another way. We'll find another way. Line cast. Yeah, totally. Overlap box. Find all the colliders touching inside the given box. Bro, this doesn't give us true or false. But that's okay. Hold on. We don't want true or false. If it's going to always detect us, we can use this instead. Overlap box finds all the colliders. We are going to be one of them. And we could just say if there's any other one. Yeah, if we're touching anything else. Yeah, right. Okay. Bro, this is what we need. If I look at this tooltip, it's telling us this is in the physics class, dot, and it's called overlap box, and then there's the parentheses, and here are the input variables, just like the input variable we put here. I hate stopping in the middle of a sentence to cough. Please give me one moment to pause and correct my throat. Thank you. All right. I get so excited. I don't want to stop. Large, non-interruptible blocks of time becomes more valuable as you do this work. Okay. Physics. This is the class we were playing with. I can spell. Physics. And we knew that because we were dealing with collision, and it just so happens there is a physics class. Okay, we found something called overlap box, and I'm looking at this tooltip, and it says, yeah, there's some variables that need to be entered here. It also says this +3 overloads. An overload is like the same function definition, but with different inputs. In other words, a duplicate of the function, but different inputs. So the name is technically different. Otherwise, you can't do it. But an overload has different inputs so that you can have different versions of the same function. And so I am going to type overlap box after the dot. And then I'm going to type the first parentheses. And the reason why I'm being very specific about explaining this. Oh, pardon me. I just realized I went over an hour already. My goodness. I'm so sorry. I need to keep going, and I cannot stop. This would be a very, very bad place to stop. Please forgive me. I try to do this in an hour, and that's not going to happen today. It's all right. We'll get there. It said there were, I hate stopping in the middle of a sentence. Doggone it. Overlap box. It said 3 overloads, and the way I'm looking at the overloads is I go ahead and auto-complete the word and type the first parentheses, And look what Visual Studio is doing now. It says 1 of 4, and it has these arrows, and I can go up and down, so I can look at the other overloads. These are the other versions of the same function, and look how the input changes. That's why there are overloads. And this one looks really simple. Can we just do this? Let's just do the simple. This is going to ask for a vector3 center. Well, we know where that is because we're going to take our game object position and add the direction times this distance. Yeah, dir times dist. Yeah, totally. We know what that is. And then vector3 half extent, like the distance from the center. Okay, this is like a radius of a circle, but we're doing a box, so it's the distance to the edge. And because it's a box or square, it should be the same. It's just a number. Oh, but it's vector3. Oh, so you could have like a rectangle. Oh. All right. Well, it doesn't matter. Our we're not doing anything in Z, and our thing is a square, so we'll just use the half extents. We'll use vector 3.1, and we'll multiply times 0.5, I think. I don't know. I think that's true. Where we are, or actually where we are based on this direction times this distance added to our current position, because that's a tiny little move that we're checking, and we're seeing if we're touching anything at that other position. Okay. And at that half extent, I think it's just 0.5, in all directions. That's cool. What we're going to get back, though, is something interesting. This is a return value that is a collider. It's showing us what colliders we are overlapping. But it is colliders. It's plural because these square brackets are telling us this is an array, a series of colliders. It might be 0, but there might be 1. It's going to be us. And there might be more than 1. And I think that's what we're going to say. Anything other than us basically means if this returns more than 1. Oh, dude, that's easy. If the length of this array of colliders is 1, then it's just us. If it's anything more than 1, I don't expect it to be 0, frankly, ever. Because we're going to check right next to us all the time. We're going to be inside that box every time. But if there's more than 1, then it's more than just us. Okay. We are checking. Are we touching anything if we move in a particular direction? And what we're going to say is, let's check at this position, which is us. This is game object transform position, plus the distance, or the direction, times the distance. Yeah, right. But let's actually put these in parentheses so it does this calculation first. So it will do this first because math, and then it will do this second, and so it gets the resulting position for this center of the box. Yes. And now we say, cool, you also need something called half extend. You need this. Okay. Needs a vector 3. Okay. It's called half extends, and what it means is the distance to the edge from the center, because we just defined the center position. This needs to detect the edge of it, so I say it's just a square. It's actually a square of a length of 1, but the half extends would be 1 times 0.5. I'll put an F on there because of float. This function, oops, and I hit the semicolon at the end, and it sort of reformatted this because Visual Studio doesn't like to make it so readable, I guess. I don't know. Anyway, this function can now be called. The key, though, is that it's going to return some stuff. A number of colliders. And I am guessing that number is going to be 1 or more all the time because we're going to be one of them. Actually, we should test that theory. How do we test that? We can print how many. Yeah, let's get a variable in here just to make it easy. I'm going to say how many. I know. How many equals 0 to begin with. Okay, fine. But I'm going to say so when this function is called, it returns a series of colliders, and well, we have two things we can do. One is we can make a variable that is exactly this, an array of colliders, and then we can check it. Or we could actually go to the end of this function call and hit dot, because that's exactly the same thing. This is now the return value of this function. This is an array of colliders at this point. I could even ask length, actually, right here, length. I could totally do that. I could totally do how many equals that. Because I'm asking to go call that function in physics overlap box with these things, and the return value is now here, and I say how many is that? And it tells me. I think. Wow, we need to test. I mean, honestly. Let's just make it explicit. I'm going to say how many equals the value of how many, and print that. Fair? But we do need to test, and we're going to test every single frame, it looks like, so it's going to be very noisy, but that's okay. We're just testing. And what we're testing is, well, first of all, this is always going to be false still. We haven't changed that at all. This is always false. It starts out false, it ends false. So this is always going to move still the same way, but we're getting some new information in a console, so we're going to look at that. That's all we're testing. What we're looking for is a number in the console. So, okay, here it is. I waited until it was actually printing something. It says how many equals 1, so I was right. It's totally us. Now, what happens if I touch a wall? Well, it says how many equals 2. In fact, I'm going to collapse this. I am collapsing it. That's interesting. Yeah. How many equals 2? Okay. Oh, how many equals 3? Check it out. Yeah, 4. So this is... So, okay, first of all, yay. We can do a test, and we can see how many things are we colliding. And yeah, colliding with 4 different things at once. Yeah, this is total garbage. And what we're testing is, let's check a tiny little box in the position where we're trying to go in that direction. And yeah. So, and we're always 1. That's actually what I wanted to see. If I stop, pardon me, excuse me. If I stop and play again, I am seeing that no matter what, if we're moving, we are 1 for sure. We're one of the things that is solid, and we can always see that. If we run into a wall, we're seeing it say 2. I'm seeing this number tick up right here. We're collapsed, so it's literally doing it right now. Yeah, you can see it a little easier if I uncollapse. 2, 1, 2, 1, 3, 2, 4. Yeah, that's the problem. I mean, yay. See, we saw the problem, and we're reproducing the problem while our code is able to detect the problem. This is the key. This is now our key to be able to say, And we don't need this anymore. We did the test. The fact that we can detect that this length is more than 1 is whether we should be saying we're touching something or not. Are we touching anything? If this is 1, then no, it's actually just us. But if it's more than 1, then the answer should be yes. It should be true. This return Boolean value should be true if this length is more than 1. Let me say that a different way while I type some code. I'm going to get rid of this. Boop. I'm going to get rid of this. Boop. And I'm going to say return bool equals true or false. And this is now going to be just a thing, a very long thing. But we saw the result of it. It's like 1 or 2 or 3 or 4. I'm just saying, yeah. If all of that is more than 1, done. Right? Because 1 is us. Anything more than 1 means we're touching something else, something other than us. And so now this is true. We return true, which means we are touching something, which means this is not false, which means we should not add that direction, which means don't go that direction. That's going to be a wall, bro. Now, it's because we tested and tested and tested. That's where we got to this point. We tried a couple of different things, to be fair. We got super lucky finding something called checkbox and then overlap box, but here we go. Our little guy, isn't he cute? And I can move, and the moving is still awesome. We haven't changed the actual movement. That's the beauty of this. Now, I'm going to go run into this wall. Oh, and it makes us look at the camera. Right, because our move direction hasn't changed. It's 0. Oh, wild. But we're not jittering. There's that. We are not jittering. It makes us sit still, and so we look at the camera. I hadn't thought about that, but it's true. The animation script looks at how our move direction is doing, and it detects, yeah, you're at 0, 0, 0. So therefore, okay, so when I try to left into the wall, I'm just holding it down, and it stops. And it also, I'm still holding it down. It just has us looking at the camera and blinking. That's beautiful, actually. No jitter at all. Yeah, man. I think that means I can try and cheat now. And, well, I can't diagonal through the walls anymore. Unfortunately, I can also not get in this hallway anymore. Okay. Well, wait a minute. Problem solved, first of all. I cannot diagonal through these walls. Oh, I absolutely cannot. Yay. So I'm like literally trying to get in there the same way we did before. We found the bug and we are consistently trying to reproduce the bug. And now that we fixed it, we can try and consistently reproduce the bug, and I cannot, which means we fixed the bug. Unfortunately, there's a new problem, which is not really a bug. It's just that these walls are too close together. I think that's true. Let's test that theory. This kind of actually confirms what I was thinking before. This hallway was just big enough for the character, but literally we had to cheat to get inside. I think that's exactly what was going on, because now we can't cheat, and so I can't get inside. I think that's true. What happens if I make, I'm going to hold down control and select all the wall pieces at the same time, and I'm just going to try and adjust the width of them. I'll just make it real thin for the moment. This, I think we decided, was like way too thin visually for the walls. But, so again, I just control selected all the wall pieces and adjusted the X thickness. It doesn't matter what direction they're oriented right now. Excuse me. I'm trying to move very fast right now. Trying to finish. We're almost done. I mean, we are done. We fixed the bug, but we need to solve this problem too while we're here. The thinner walls should give us more room. So again, I cannot cheat through. That's excellent. But now I want to see if I can get in. And I can. Yeah, because there is actually some room in between. And I'm not able to go through the walls. It does stop me and make me look like I've stopped the controls, like I'm literally going to the left. And I'm still holding it down, but it made me stop and blink the camera. So that's what the wall does now. But that also means, so can I, wait, so I'm going to go diagonal now. Okay. So that looks smooth. See, this took away all the jitter. This took away all the jitter because we're no longer actually teleporting if it's going to result in a collision. Okay. Yeah. So we can actually slide. Now, that I was hoping that was true, and I'm kind of glad that that's true. And so I don't really want walls this thin, to be fair. I don't. You know, maybe we can have thick walls and thin walls, but yeah. Good. Hey! Walls, plural. Okay, we fixed a bug, too. And that was a pretty big bug. So, cool. I'm sorry it went long. Let's wrap it up then. I mean, yay. Right? If that's true, we're in a test scene right now, but let's just go to the menu. Yeah, we'll save it here. That test scene got saved, yes. But let's play. I mean, this should still work, right? I mean, there's no walls yet, so of course this still works, yeah? And here's the wall for level 2. Our testing in design chat said, well, we're going to want more than this. And it looks good. So I think what we've done is approach a problem that we found, and we were glad to find the problem. Let's be clear about that. That was a good thing that we saw the problem that a player would see, because that means we have the opportunity to fix it. If we didn't find it and we ignored it, you know, bad designer, bad. Because we want to take the opportunity to make things better. We are given the opportunity to make things better, right? If only we pay attention to the bug. So it's good. This cartoon ape likes to make games as well as play games. And I might go long sometimes. I apologize. I'm going to blame my throat on that. And I'm going to drink more coffee, and I'm going to probably play some games later today. So if you're interested in that kind of stuff, making or playing games, then follow and be notified and show up on stream. And when you do, please use Command Tie. Because Command Tie lets me know that you are here. In the meantime, have fun, do well, be good, stay safe. See ya.